Okay. When I say parent functions, what do you think I mean?
Like the most simple one?
Yeah, right. That's exactly right. The most simple, the base, right? The base of each of those functions that hasn't been moved left to right, up or down, hasn't been stretched or compressed. The size hasn't changed, okay? What would be the first function there? What kind of function is that?
Linear.
Linear function, good. Linear function. Okay. If we graph that y-intercept's 0, the slope is 1, so we're up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, down 1, left 1. Okay. So, looking at that line, looking at that linear function, what would the domain be there?
All real numbers.
All real numbers. And what would the range be?
All real numbers.
All real numbers. Good. All right. That second function, what kind of function would that be?
Absolute value.
Absolute value function. Good, good, good. How'd you know it was an absolute value function?
And the absolute value bars.
Yep, because it has absolute value around x. Okay. So when graphing that, our base, absolute value function, our vertex is at 0, 0. If I plugged 1 in for x, what would I get?
Find 1 and -1.
You get 1, right? If I plugged in 2 for x, what would I get? 2. If I plugged in 3 for x, what would I get? 3. If I plugged in -1 for x, what would I get?
1.
1. If I plugged in -2 for x,
-2.
you get 2, right? Absolute value of -2 is 2. If I plugged in -3, what would I get? 3. All right, because that absolute value, we get that V shape. The right side mirrors the left side. The right side mirrors the left side. What would the domain be there?
Negative infinity, infinity.
Yep, all real numbers. And what would the range be? 0 to infinity. Good. 0 to infinity.
Why is it when you plug in negatives for the absolute?
So, what is this next function?
Quadratic.
Quadratic, good. All right. Again, our vertex will be at 0, 0. Okay. So, if I plug in 2, or, so, blah, 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 sorry. If I plugged in 1 for x, what's 1 squared? 1, good. If I plugged in 2 for x, what would that give me?
4.
4. If I plugged in -1 for x, what would that give me?
8. Oh, wait, no. 1.
Yep. If I plugged in -2 for x, what would I get? 4. So similar to the absolute value, the right side's going to mirror the left side. All right, we'll get our quadratic. So what would our domain be here?
All real numbers.
All real numbers. Good. And what would our range be?
0 to infinity.
0 to infinity. Good. Okay. What's our next function?
Cubic.
Cubic, good, right? That's x cubed, exponent of 3, x cubed. Yep, it's going to have 2 terms. So that's since it's cubed, it's going to be a cubic function. Okay. Again, our vertex will be at 0, 0. If I plugged 1 in for x, what would I get?
1.
1. If I plugged 2 in for x, what would I get? 8. 2 cubed is 8. Be 1 off the graph. Okay. If I plugged in -1 for x, what would I get? -1. Good. -1 cubed is -1. If I plugged -2 in for x, what would I get?
-8.
-8. Good. And get our cubic function. What would the domain be there?
All real numbers.
All real numbers. Goes to the left forever and the right forever. What would our range be? All All real numbers. Goes up forever and down forever. Yeah, we got two more functions. All right, y equals the square root of x. What do you think that function is?
Square root.
Square root function. Again, square root function. All right, so for right now, can we take the square root of a negative number? No, not right now, but it is imaginary, correct. So we'll start with 0. What's the square root of 0? 0. What is the square root of 1? 1. So we have a point at 1, 1. So you could do 2, 3, but they're not perfect squares. It's nice and clean if we use 4. So square root of 4. 2. So point at 4, 2. We get our square root function. Square root function. What would be our domain here?
0 to infinity.
0 to infinity. 0 to infinity there. And what would our range be there?
0 to infinity.
0 to infinity. Very good. Yeah. All right. Last. What do you think the name of that function is?
Cubic root.
Not a cubic. You can just say cube root function. Okay, cube root function. I put cube root f because I couldn't get function to fit. All right. So you can take the cube root of a negative number, right? Okay. So here, what's the cube root of 0? 0. All right. What's the cube root of 1? 1. 1, 1. All right, so next one here. I wanted to use a nice clean number. What's our next perfect cube root? 8. All right, what's the cube root of 8? 2. Oops, I didn't that one. So I had a point at 8, 2. It's just off the graph. Put a point at 8, 2, right? Again, you can do a decimal. You could do square root of 7 to keep it on the graph. That'd be like 1.89 or something like that. All right, next, plugged in -1. Cube root of -1 is? -1. And then I did the cube root of -8. Should be -2 there. Okay. So, what would our domain be here?
All real numbers.
All real numbers. Left forever, right forever. What would our range be here?
All real numbers.
All real numbers. Up forever, down forever. Now it does, like it goes up forever and down forever, but it goes at such a small rate, right? Really, really, really small rate. But it's still going up forever and down forever. Okay. All right, let's get into the transformations here, okay? So, right here, we have the vertex form of an equation. Okay, we're gonna go over reflecting across the x-axis, vertical stretches and compressions, horizontal shifts and vertical shifts. Okay, so if we're looking at this equation right here, we're gonna have A. A is gonna give us our vertical stretch and compression. When we think about a vertical stretch and compression, think about a marshmallow. If we stretch a marshmallow, it's going to get skinnier up and down, right? If we compress a marshmallow, it's going to get wider, right? So same will apply with these functions, okay? Now, when we look at A, we always treat it as if we always view the compression or stretch based on what it would be if it's a positive number. Okay, so put absolute value around that A. Put absolute value around that A. You'll see why as we do these. Okay. Next, if A is negative, that's going to reflect it across the x-axis. If A is negative, it reflects it across the x-axis, it flips it. H is going to give us our horizontal shift, left and right. It's going to give us our horizontal shift, left and right. Okay? So, because in parentheses, it is x minus h, whatever number is in there, whatever number h is, when given, it's going to be the opposite of what's in parentheses. H will be what's opposite of what's in parentheses. I'm going to go over that on the board real quick. So, next we got K, and that tells us our vertical shift up or down, okay? And so whatever K is, that is going to be the number. If it's plus 5, it'll be up 5. If it's minus 5, it will be down 5, which plays into that first equation, y equals x squared minus 3. That minus 3, what do you think that's telling us?
Shifted down 3.
Yep, down 3. Down 3, okay? So, that means in that equation, h would be 0. That's x minus 0 squared, but you don't write it like that, okay? So, what would that parent be?
Y equals x squared.
Yep, it's quadratic, good. And like y'all said, that transformation would be down 3. Okay. Next example. What parent would that be?
Square root.
Yep, square root function, good. Y equals square root of x. What would that transformation be?
Shifted left 5.
Left 5, good. Left 5. Remember that is minus a negative 5. So that will be left 5. Minus a negative 5. Left 5. All right. Next one, it gives us a transformation. A linear function shifted down 2. What would the parent be?
Y equals x.
Y equals x. It would be linear. How'd you know that? Tells you. Tells you. That was pretty... Oh, shoot. That was pretty funny, right? Sure. Dang. Tough crowd. All right. So, if it was shifted down 2, what would that equation be? Y equals x minus 2. Good. All right. What would be the parent of our next equation? Y equals x, which is linear. Okay. So that negative out in front of the x tells us it's going to be a what?
Negative slope.
Reflected over the x-axis.
Yes. So I'm looking for reflection. It would be a negative slope, yes. But it's reflection over the x-axis. Okay. Good. All right. Next example, y equals x plus 5 cubed. What's the parent there?
Y equals x cubed.
Yep, cubic. What would be the transformation there?
Left 5.
Left 5. All right. Next one, a cubic shifted up 3. What's the parent, Gavin?
Cubic.
Cubic. How'd you know that, Gavin?
Because it said cubic.
All right, so what would that equation look like?
Y equals x cubed plus 3.
Y equals x cubed plus 3. All right, next one tries to trick you. They can't trick you. Y equals x plus the square root of 3. Square root of 3 is just a number, right?
Yeah.
Right? It's like, it's 1.73, right? Or 1.79, 1.73. But either way, what's that parent function? Linear. And what's the transformation?
Up
Yeah, you could say up square root of 3 or 1.73. All right, I'm not going to do the joke this time. A quadratic shifted 4 to the left. What is the parent? Quadratic. Okay. All right, quadratic shifted 4 to the left. What would that function look like?
Y equals 4 squared.
Good. Y equals x plus 4 squared. Okay. All right. 3 more. Y equals x plus 14. Linear. And what's the transformation? Up 14. Good. All right. So the next one's here. We're going to go over it, and then I'm going to do some visuals on Desmos. Okay. But y equals 1/3 x. So it's linear, yep. And a is 1/3. A is less than 1. Okay. If a is 1/3 less than 1, that's going to give us a vertical compression. Vertical compression. The next example, a is 5. A is greater than 1. A is 5. That will give us a vertical stretch. Okay? That will give us a vertical stretch. So, I am going to show you all that on Desmos. All right, here we go. First function, what's the parent? Quadratic. What would the transformation be there?
Left 3 and left.
Right, a reflection and left 3.
Left 3. I told you, Jackson.
Minus a negative 3. Minus a negative 3. All right, the next function? Linear.
So all the ones that you said were right, were left, they were right.
All right, and then what's that negative mean?
Reflection.
Reflection.
Up 4.
Good, and up 4. All right, next example. Cubic, good. And then it would be
Up 4, right 2.
it'd be up 4 and right 2.
That was a 2. Or a 3.
Huh?
All right, next example, it is linear.
Yes.
And then the 1/5 tells us it's a
Compression.
compression. And then it is
Down 2.
down 2.
Compression that goes under the hydraulic press.
All right. Y equals, all right, the negative 4 out in front. The negative tells me it's a
Reflection.
reflection. The 4 tells me it's a
Vertical stretch.
stretch. Good. And then the 2 inside of the radical,
Right 2.
right 2.
Really indecisive about that.
I can't remember what happened there. I appreciate the call out. Next one, the negative tells me it's a reflection. The minus 2 inside of the absolute value means it's
Right 2.
right 2, right? It's minus h. H is 2. And then outside of the absolute value, the plus 5s tells me it's
Up 5.
up 5.
You're not forgiven.
David,
Why
I
would you
see.
say that?
Hey, I see a lot of stuff crossed out on that paper.
Because I trusted you. Let me down.
All right, next one is a cube root function. What's the what's the 1/2 telling me? Vertical compression. And then that minus 2 is outside of the radical, so it is down 2. Okay. All right. Next, 5/4 outside of A is 5/4. So it's a stretch. Good, because 5/4 is greater than 1. 5/4 is 1.25. So we got a vertical stretch. Good. 2 inside of parentheses tells me it is right 2.
And then up 4.
4 outside, up 4.
I know I got that one.
All right, y equals x squared plus 10. Only one transformation here. Quadratic, up 10. All right, last one here, y equals negative third to the y equals, the negative tells me it's a reflection. The 2/3 tells me it's a compression. And minus 2.5,
Down 2.5.
down 2.5. Good job.